Hello all, good evening. Welcome to Unacademy. Today we will going to discuss a topic which is most important topic and many questions asked on that topic. So we will take a complete revision on that topic, that is linear algebra. Okay. Now before going to start this, let's see. Crack GATE ESE with India's largest learning platform. Before going to start this, let me introduce myself. Myself Dhanashri Prasdevkar. I completed my MSc in Mathematics from Mumbai University and also having 13 plus years of teaching experience, I mentored more than 10,000 plus students for the engineering. Now here how to install the Unacademy's learning app. Now what you will get in an Unacademy, you will get daily live classes, live tests and quizzes, structured courses, unlimited access. You will get in the plus courses and iconic subscription. You will get personal coach. What do you mean by personal coach? You will get one-on-one guidance from the top exam experts as your personal coach. Align your preparation strategy and learning resources. You will get mains and question and answer practice. Strengthen your mains and answers writing through the regular practice with evaluation and personalized feedback. Now you will get a study tracker. So all benefits of plus you will get here. No. Plus subscription you will get daily live classes, live test and quizzes, structured courses, unlimited access. No. Learn with the top educators. You can learn with the top educators of Unacademy. Here is Marut Tiwari sir, Ankit Goyal sir, Jaspal Singh sir, Sanjeev Jain sir. So you will get the guidance of top educators of Unacademy so that you can take your study to the next level. Now these are the some top educators of Unacademy. Now there are many courses are available here GATE and ESE. Just like there are 38 courses are available for GATE and ESE here. You can see the mechanical engineering. There are many branches of each and every branch of engineering. There are many courses are available. For the mechanical engineering there are 24 courses. For electrical engineering there are 18 courses. For ECE there are 10 courses and such on. Okay. No. So for plus subscription, in short, you will get in a plus subscription plan. For India's best educators, you will get interactive live classes, you will get structured courses and PDFs, you will get live tests and quizzes also you will get. Now in an iconic subscription, you will get India's best educators, interactive live classes, structured courses and live tests and quizzes. Now in this you will get personal coach. Most important benefit to select the iconic plan is you will get a personal coach. With the help of personal coach, you can resolve your any query with the help of the personal coach. Now, personalized test analysis. So, whatever you have studied, so you can test your knowledge with this personalized test analysis. Now, study planner also you will get how to prepare and how to categorize your preparation and how to study in a well manner. Now, preparatory study material also you will get. So, everything is systematically given to you. So this is the most important and beneficial plan for you, that is iconic subscription. Okay. Now, if you are going to prepare for the here, so if you take the 12, if you are going to prepare for the GATE 2022 now, so I will suggest you can go for the 12 months plan. So it will cost you 30,250. But if you use my promo code DSP, then the same plan it will cost you 27,225. As I told you here, in the every lecture from the last week, that this 10% subscription will be limited days, will be available for the limited days. So enroll your name as early as possible to get the 10% discount on your subscription fees. Okay. Now, if you are going to prepare for the 12 months plan, so exactly similar, the iconic plan will be cost you 50,250. But instead of, if you are going to prepare for the, if you are using my promo code DSP, so you will get a 10% discount on it. The same plan will be cost you for 45,225. So enroll your names as early as possible to get the 10% discount No, the most important thing here, our batches for the next GATE exam, that is GATE 2022, are already started for the civil engineering. For batch C is started for the civil engineering from 25th of January 2021. So you can see here 25th of January 2021, our batches for the civil engineering are already started. Now to enroll in this batch, you can use my promo code DSP to get the 10% discount. Now here assigned for the GATE 2023 also started for civil engineering. Your new batch alert you will get for the GATE 2023. So here you can see, to enroll in this batch you will get a 10% discount if you use my promo code DSP. So hurry up and enroll your names in these batches. So evolve for the GATE 2022. For the chemical engineering, the batch A is already started here. So 25th of January 2021. So to enroll in this batch, you can use my promo code DSP to get the 10% discount. As I told you earlier, that this discount percentage will be reduced after some days. So discount will be valid to the limited days. So you can enroll your name as early as possible. Similarly, for this mechanical engineering also assigned for the GATE 2023, the batches started from the 25th of January 2021. So already started, so you can enroll your name in this batch and use my promo code DSP to get the 10% discount. Okay, now come back to the actual syllabus. Okay, so many times what happened, many of the students are not aware of how to find out the rank. I will tell you how to find out the rank in a simplest manner. Okay, so with the simplest manner we can find out the rank of this matrix. Instead of using the definition of a rank, here we will find out the rank of the matrix. Given matrix A is 4 2 1 3 6 3 4 7 2 1 0 1. The rank of the matrix is, for the civil engineering, it is given GATE 2003 for the 1 mark. Okay, so let's start. So what we will do, we will use the row echelon form to get the rank, and that is very easy way you can use it. So here see, what I will do, I will interchange R1 interchange with R3, so it's more better to do the calculations here. 2101 6347 and here is 4213. Okay, so which transformation I have to do? Yes, I will do the transformation here. See, R2 minus 3R1 and R3 minus 2R1 we will do. R2 minus 3R1 and R3 minus 2R1. So you will get here 2101 R2 minus 3R1, 6 minus 6 you will get 0. So instead of doing in this way, so without doing any calculation mistake, we can do it here. R2 is 6347 minus 2R1, 3R1, so 6303. So immediately we'll get 0044, right? 0044. Now 4213. So you can get R3 minus 2R1, 4213 minus 2R1. So here is R3 minus 2R1. So 4, 2, 0, 2, 0, 0, 1, 1, 0, 0, 1, 1. So what we will do? We will do R3 right? Here we will do R1 interchange with, immediately we will get R1 in R2 interchange with R3. So 2101 0011 0044. So what we will do? R3 minus 4R2. So immediately we will get 000, right? So after R3 minus 4R2, You will get 2 1 0 1 0 0 1 1 0 0 0 0. Now you are very smart and very familiar with this. You are already two exams are done. Now for the remaining, for the 14th of February, the remaining exam is there. So already you are prepared very good way. So this is just, we are taking a complete revision on this. So definitely the rank of this matrix, the total number of rows are 3 and number of rows containing all 0 is 1. So 3 minus 1, the rank is 2, right? So 2 is the correct option. Now, consider the system of simultaneous equations. X plus 2y plus z is equal to 6. 2x plus y plus 2z is equal to 6. X plus y plus z is equal to 5. This system has, okay, so we will get here the matrix given system can be written in the matrix form 1 2 1 2 1 2 1 1 1 of x y z is equal to 6 6 5 of x y z is equal to 6 6 5. Now augmented matrix for this is 1 2 1 2 1 1 1 2 1 6 6 5, right? So by Gauss elimination method you will get R2 minus 2 R1 R3 minus R1. 1 to 1, R2 minus 2, R1, 2 minus 2, 0. R2 minus 2, R1. R2 is this minus 2, R1. Six minus 12 minus 6. Right? Here R3 minus R1, 0, minus 1, 0, minus 1. Right? So now we will get R3 minus 1 by 3 R2. R3 minus 1 by 3 R2. So you will get 1 to 1, 6 here, 0 minus 3, 0 minus 6 and 0 0 0 5. So rank of this matrix is again 2, right? As rank of a augmented matrix, so system is inconsistent. Rank of A is equal to 2 and rank of augmented matrix is equal to 3. So system is inconsistent. No solution. Option C. Consider the following system of linear equations: 2 1 minus 4 4 3 minus 12 1 2 minus z. Here x y z is equal to alpha 5 7. So let's calculate. Notice that the second and third columns of the coefficient matrix are linearly dependent. For how many values of alpha does this system of equations have infinitely many solutions? Okay, so we will go for it. The augmented matrix for the given system. So we'll get the augmented matrix for the given system: 2 1 minus 4 alpha, 4 3 minus 12, 5, 1 2 minus 8 7. 1 2 minus 8 7. So you will get alpha minus here R2 minus 2 R1. R2 is here 2 1 minus 4 alpha, R2 minus 2 R1 0 1 minus 4, 5 minus 2 alpha. So here is 0, 0, 0, 5 alpha minus 1 by 2. Right? Now this infinite solution is necessary. At least one must be completely 0. So we'll get 5 alpha minus 1 by 2 is equal to 0. So alpha is equal to 5 alpha is equal to 1. So alpha is equal to 1 by 5. So there is only one value of alpha which is infinite solution exists. Okay. So the correct option is B. Now let's see. For the matrix 4, 1, 1, 4, the eigenvalues are 3 minus 3 minus 3 minus 5, 3, 5, 5 and 0. Right? So for the matrix 4, 1, 1, 4, A minus lambda I is equal to 0. So where lambda is equal to eigenvalue. So we will see 4 minus lambda. So characteristic equation. A minus lambda I is equal to 0. 4 minus lambda 1, 1, 1, 4 minus lambda is equal to 0. So 4 minus lambda bracket square minus 1 is equal to 0, or 4 minus lambda bracket square minus 1 square is equal to 0. So 4 minus lambda plus 1 into 4 minus lambda minus 1 is equal to 0. So 5 minus lambda and 3 minus lambda is equal to 0. So lambda is equal to 3 and lambda is equal to 5. So 3 and 5, option C is the correct option. Okay, it's a very simple question for 1 mark. For which value of x will the matrix given below become singular? Okay, for which value of x matrix becomes 0? For which value of x the matrix becomes 0 for the singular? So 8x 0, 402, 1260. So here you will get for singularity of a matrix. So calculate determinant. 8 into 0 minus 0 minus x into 0 minus 24 is equal to 0. So you will get x is equal to minus 24x is equal to 0. 0 minus 12. Right. So minus 24 minus 96 minus 24. Here minus minus plus 24. So 24x is equal to 96. So x is equal to 4. So 4. For which value of matrix becomes singular? For x is equal to 4. Singular, it means determinant of a is equal to 0. Right? Now, let A, B, C, D be n by n matrices, each with a non-zero determinant. If A, B, C, D is equal to 1, then B inverse is. So what is B inverse? So you will get here A, B, C, D is n by n matrix. Right? A, B, C, D is n by n matrix which is equal to 1. So multiplying by D inverse, C inverse, post multiplying by D inverse, C inverse. So you will get A, B, C, D inverse, A, B, C, D, D inverse, C inverse. So which is equal to D inverse, C inverse, post multiplying by D inverse and C inverse. So as we know that AB into C, D inverse D, it means identity. So C into C inverse is equal to D inverse C inverse. But C into C inverse is again identity. So you will get AB is equal to D inverse C inverse. So what we will do, we will post pre-multiplying by A inverse on both sides. So A inverse AB is equal to A inverse D inverse C inverse. Right? So B is equal to A inverse D inverse C inverse. So B inverse is equal to, here taking inverse on both sides, B inverse is equal to A inverse D inverse C inverse of inverse is equal to, so B inverse is equal to A inverse of inverse A, D inverse of, so you will get C inverse first, then D, and then E. So B inverse is equal to C, D, A. So which one is the correct option? Option B. Okay. Now let's see the next one. How many solutions does the following system of linear equation have? So first we will convert it into augmented matrix. So for the given equation, we can convert it into augmented matrix. Only two variables are there. So we can write here augmented matrix as -1, 5, 1 minus 1, 1, 3. Here is -1, 2, 3. Right? So using Gauss elimination method, we will calculate here rank of this matrix. So we can see that R1 plus, R2 plus R1 and R3 plus R1. So we'll get 0 here. -1, 5, R2 plus R1, 0, -1 plus 5, 4, and here 1 minus 1, 0, and 3 minus 5, -2. 3 minus 5, -2. Here is R2 plus -1 as it is. R2 plus R1, 1. R3 plus R1, 2. Right? So we can calculate here. -2, 2. 3 plus 8. Okay, 3 plus 5. Here is 8. R3 plus R1. So 2. Now we can use the operation R3 minus 2R2. So you will get -1, 5, 0, 4, -1, 1. R3 minus 2R2. So 0 minus 0, 8 minus 8, 0, 2 minus 2, 0. Okay, now we will get the row echelon form here. So after getting the row echelon form, we can find out here 4xy. So rank of matrix A is equal to rank of augmented matrix. So the unique solution. This will, so number of unknowns rank is equal to 2, right? Which is equal to the number of variables. X and Y, two variables. So rank is same. So you will get the unique solution. Right? If the rank of the matrix is same as the rank of the order of the matrix is same as the rank of the matrix, number of unknowns are same to the rank of the matrix, then definitely this will have a unique solution. So this system will possess a unique solution. Okay? System will possess unique solution. Now see, the eigenvalues of the matrix 4 minus 2 minus 2 1 are. So eigenvalues we have to find out. So for that, write down the characteristic equation. So characteristic equation is determinant of A minus lambda I is equal to 0. So determinant of A minus lambda I is equal to 0. So calculate here, you will get A minus lambda I is 4 minus lambda minus 2 1 minus lambda is equal to 0. So you will get 4 minus lambda into 1 minus lambda minus of minus 4. So you will get here uh, minus 4 is equal to 0. Right? So 4 minus 4 lambda minus plus 4 minus 4 lambda plus lambda square minus lambda minus 4 is equal to 0. So we'll get lambda square minus 4 lambda minus 5 lambda, and 4 minus 4 cancel out, so you will get 0. So lambda square minus 5 lambda is equal to 0. Lambda square minus 5 lambda is equal to 0. Take lambda common, lambda minus 5 is equal to 0. Either lambda is equal to 0 or lambda minus 5 is equal to 0. So either lambda is equal to 0 or lambda is equal to 5. These are the eigenvalues of the given matrix. So 0 and 5. Option C. Okay, I hope you are getting it clearly. Now, next question. The sum of the eigenvalues of the matrix given below is. Sum of the eigenvalues of the matrix given below. We know that sum of the eigenvalues the trick, right? So here we know that the formula, no need to find out the eigenvalues. by using the method. Okay, it's a time consuming process. We know the property, the sum of the eigenvalues is equal to sum of the diagonal elements, a11, a22 plus a33. Just take the sum. 5 1 plus 5 plus 1, which is equal to 7. So sum of the eigenvalues is 7. Okay, it's a simple technique. Now consider the matrices x of 4 by 3, y of 4 by 3 and p of 2 by 3. The order of p x transpose, p into x transpose y inverse into p transpose of transpose will be. Okay, it's a very interesting question. Now see, the order of this matrix we have to find out. So how to find out the order of this matrix? Now let's see. See, x transpose is a 3x transpose. So x is a 4 by 3, right? X is a 4 by 3 order. So x transpose is 3 by 4 order, right? So y is here 4 by 3. So y transpose is 3 by 4, correct? So x transpose into y. X transpose into y. So 3 by 4 into 4 by 3. So x transpose into y is equal to 3 by 4 into 4 by 3. It means 3 by 3 matrix, right? Now it is 3 by 3 matrix. Now x transpose y inverse is equal to, here x transpose y inverse is equal to 3 by 3 again. Okay. Now P is a matrix of 2 by 3. P transpose is a matrix of 3 by 2, right? Now see, here we calculated already this P transpose. Now see, here P into, let's see, P into x transpose y inverse into P inverse is equal to, so P is a matrix of order 2 by 3. See, I am calculating directly here. X transpose y, we already calculated x transpose y inverse is 3 by 3 matrix. It is 3 by 3 matrix. And P inverse is 3 by 2 matrix. Right? So we can calculate here. See, 2 by 3 into 3 by 3. So you will get 2 by 3 matrix. 2 by 3. And here 3 by 2. Right? So we will get P into this is 2 by 2 matrix. Are you getting it? How to calculate the matrix? So it is 2 by 2 matrix. Now see, this is a question of 1 mark only, but you have to solve it very carefully. Okay. Now, given the orthogonal matrix, given orthogonal matrix A into A transpose inverse is A into A transpose inverse. We know that the orthogonal matrix for the A into A transpose is equal to identity. A into A transpose is equal to identity matrix. A into A transpose inverse is again identity matrix. Right? And inverse of identity matrix is again an identity matrix. So which one is the correct option? C. Yeah. Now let's move further. If R is equal to 1 0 minus 1, 2 1 minus 1, 2 3 2, then top row of R inverse is. Okay, only we have to calculate the top row of R inverse. We know that R inverse is equal to 1 upon determinant of R, 1 upon determinant of R into adjoint of R. Right? So it means we have to calculate the first row only. So we will calculate the cofactor of 1 1, cofactor of 2 1 and cofactor of 3 1. That's it, to get the first row. Okay, so cofactor of 1 1 we will calculate. So cofactor of, why we are calculating only this? Because we required only first row. So cofactor of 1 1 is plus 1, 1 minus 1, 3 2, 1 plus 1. So 2 minus 1 raised to 1 plus 1 is 1 plus 1. So determinant of this is 2 minus of minus 3, 2 plus 3, 5. Right? Now cofactor of 2 1 is equal to minus of, you will get 0 minus 1, 3 2, which is equal to minus 3. And cofactor of 3 1 is equal to 3 plus 1, 4, 3 plus 1 6, 6 and here so positive, so we will get positive. So 0 minus 1, 1 minus 1. So determinant of this is 0 minus of minus 1, so plus 1, right? So cofactor of A is equal to, you will get 5 minus 3, 1. 5 minus 3, 1. And this is, again you will get the same things. Now, so adjoint of A, cofactor transpose. Adjoint of A is cofactor transpose. Cofactor of A transpose. So row becomes column, column becomes row. So this is 5 minus 3, 1. Right? So top row of R inverse, you will get 5 minus 3, 1. Clear? Now, let A is equal to 2 minus 0, 1, 0, 3. A is equal to, here we will see, A is equal to 2 minus 0.1, 2 minus 0.1, and A inverse is equal to 1 by 2 A 0 P, then A plus B is. So we have to calculate the value of A and B first. Then we will calculate A plus B. We know that A into A inverse is equal to identity, right? So we'll see A into A inverse is equal to identity. So A is here 2.1 to 0.103 into A inverse is 1 by 2A 0B is equal to, now take the calculation, 2 into 1 by 2 1, 0.1 into 0 1, here is 0 and 1 plus 0 1, 2 into A 2A minus 0.1B, right? So we will calculate this here. First of all, we write identity matrix 1 0 0 1 and then take the calculation here. 2 into 1 by 2 1 plus here 1 into 0 0 2A minus 0.1B 0 plus 0 0 3 0 A into 0 0 3 into B 3B is equal to 1001, right? Is equal to 1001. So 2A minus 0.1B is equal to 0, which implies A is equal to 0.1B by 2. Or this is equation 1. So 3B is equal to 1, which implies B is equal to 1 by 3. Right? So B is equal to 1 by 3. You will get A. So put the value of A here. Value of B is equal to in this. So you will get A is equal to 1 by 60. And B is 1 by 3. Right? So A plus B we require 1 by 60 plus 1 by 3. So 21 by 60, right? 20 into 3. So 21 by 60. So 21 by 60. So 21 by 60, it means 3 sevens are 21 and 3 20s are 7 by 20. Yes, 7 by 20 is the correct option. Now let's see. Consider a non-homogeneous system of linear equations representing mathematically an overdetermined system. Such a system will be consistent, having unique solution, consistent, having many solutions, inconsistent, having unique solutions, and inconsistent, having many solutions. Okay, so we can see that this consistent and having unique solution, the system is consistent, representing mathematically overdetermined system. Such a system will be consistent and having many solutions. Okay, the system is consistent, having many solutions. If the rank of augmented matrix is less than or equal to the rank of A is equal to rank of AB and is less than or equal to the number of unknowns, the system is consistent but having many solutions, infinitely many solutions. Okay. Now, in the matrix equation, Px is equal to Q. In the matrix equation, Px is equal to Q. Which of the following is necessary condition for the existence of at least one solution for the unknown vector x? in the matrix equation Px is equal to Q, which of the following is necessary condition for the existence of at least one solution for the unknown vector x? At least one solution for the unknown vector x. Okay, so we can see here, this is rank of PQ. Augmented matrix PQ have the same rank as a matrix P. So A is the correct option. This is only for the 1 mark. Now consider the following system of equations in three real variables x1, x2 and x3. 2x1 minus x2 plus 3x3 is equal to 1. 3x1 minus 2x2 plus 5x3 is equal to 2. Minus x1 minus 4x2 plus x3 is equal to 3. This system of equations has first no solution. Now see the augmented matrix for the given system is, right? Augmented matrix for the given system is 2 minus 1 3 1, 3 minus 2 5 2, minus 1 minus 4 1 3. Okay, using the Gauss elimination method on the above matrix, we will use, see here, we can check R2 minus 3 by 2 R1, R3 plus 1 by 2 R1, 2 minus 1 3, 0 minus 1 by 2 1 by 2, 0 minus 9 by 2 5 by 2, 1 1 by 2 7 by 2. Okay, after doing the calculation you will get this. Now R3 minus 9 R2. So you will get R3 minus 9 R2. So this will become 0. Right? So it is 2 minus 1 3 1. 0 minus 1 by 2 1 by 2 1 by 2. 0 minus 9 by 2 9. So you will get 0. And 5 by 2 minus 9 by 2. So minus 2. And here is minus 1. Right? So rank of augmented matrix AP. Now this is row echelon form. Rank of A is same as is 3. Rank of augmented matrix is also 3. Right? System will have unique solution. System will possess a unique solution. Right? Now you will get, which of the following is an eigenvector of the matrix? So 5 0 0 0 0 5 5 0 0 0 2 1 0 0 3 1. Right? So which of the following is the eigenvector for the matrix? So determinant of A minus lambda I. First of all, we have to find out the eigenvalues, right? So determinant of A minus lambda I is equal to 5 minus lambda 0 0 0 0 5 minus lambda, then 5 0 0 0 2 minus lambda 1 0 0 3 1 minus lambda. 5 minus lambda into 5 minus lambda. Now it is a determinant of 4 by 4 matrix. So here you will get this 5 minus lambda into 5 minus 2 minus lambda into 1 minus lambda, right? Minus 3. So you will get 5 is equal to 0. So 5 minus lambda into 5 minus lambda into lambda square minus 3 lambda plus, lambda square minus 3 lambda minus 1. So lambda is equal to 5, 5 and 3 plus or minus root 13 by 2 is the value of lambda. So we will get here lambda is equal to, so put lambda is equal to 5 in this equation. So we will get 5 minus 5, so 0, 0, 0, 0. Then 0, 0, 5, 0, 0, 0, minus 3, 1, 0, 0, 3, minus 4. x1, x2, x3, x4 is equal to, right? So here we will get 5x3 is equal to 0, minus 3x3 plus x4 is equal to 0, 3x3 minus 4x3, solving this we'll get x3 is equal to 0, x4 is equal to 0, x1 and x2 may be anything. Now the eigenvector corresponding to this, so eigenvector corresponding to this x3, x4, 0, 0, here k1, k2 anything, like this. So 1, 1, 1, so 1 minus 2, 0, 0, like this. Okay. So for the matrix A is equal to 3 minus 2 minus 2, 0 minus 2, 1, 0, 0, 1. One of the eigenvalues is equal to minus 2. Which of the following is an eigenvector? Okay, one of these eigenvalues is minus 2. Which of the following is the eigenvector? So we will calculate the eigenvector for this. The A minus lambda is into x is equal to 0. Okay, so let's see, A minus lambda I into x is equal to 0. So 3 minus lambda minus 2, 2, 0 to minus 2 minus lambda 1, 0, 0, 1 minus lambda. Here x1, x2, x3 which is equal to 0, 0, 0. Right? So calculate the values of x1, x2, x3. So putting lambda is equal to minus 2. Put lambda is equal to minus 2 because this is one eigenvalue. And for that eigenvalue we have to find out the eigenvector. 5 minus 2, 2, 0, minus 2 minus 2, so becomes plus. So 2 minus 2 plus 0, 1. Here 0, 0, 1 minus lambda. So 1 minus of minus 2 plus 2, so 3. x1, x2, x3 is equal to 0, 0, 0, right? Which gives the equations 5x1 minus 2x2 plus 2x3 is equal to 0. So x3 is equal to 0. So 3x3 is equal to 0. Call this as equation 1, equation 2 and equation 3. Right? Equation 1, 2, 3. Now solving this equation 1, 2, 3 simultaneously, you will get 3x3 is equal to 0. So x3 0, x3 0. So 5x1 minus 5x2 is equal to 0. So put x1 is equal to, you will get 2 by 5k. So eigenvector, put x2 is equal to k. So x1 is equal to 2 by 5k. So eigenvector x1, x2, x3 is equal to 2 by 5k, x2k, and here is 0. Right? So it is 250. Give the matrix minus 4, 2, 4, 3. The eigenvector is. So matrix for this eigenvector is, we will calculate. First of all, we have to find out the eigenvalues, right? So determinant of a minus lambda I is equal to 0. So we will get minus 4 minus lambda 0, here 2, 4, 3 minus lambda is equal to 0. So minus 4 minus lambda into 3 minus lambda minus 8 is equal to 0. So lambda square, we will get lambda square plus lambda minus 20 is equal to 0. So you can do the in between steps. Okay. The lambda square plus lambda minus 20 is equal to 0. So lambda 1 is equal to minus 5 and lambda 2 is equal to 4. So corresponding to lambda 1 is equal to minus 5, we need to find out the eigenvector. Mod of a minus lambda I into x is equal to 0. So which implies minus 4 minus lambda 2, 4, 3 minus lambda is equal to 0. So putting lambda is equal to minus 5, we will get minus 9, 2, minus of minus plus 5. So 4 minus 5, so we will get 1, 2, 4, 8 of x1, x2 is equal to 0, 0, right? x1 plus 2x2 is equal to 0, 4x1 plus 4x1 plus 8x2 is equal to 0. All this is equation 1, equation 2. So since 1 and 2 are the equations, some equations, so we will get x1 plus x2 is equal to 0. So which implies x1 is equal to minus 2x2. Right? So x1 is 2x2 minus 2 is to 1. So x1 by x2 is equal to minus 2. So of this form we'll get minus 2 1, minus 2 1 or 2 minus 1 is the correct option. Right? What are the eigenvalues of the following? What are the eigenvalues of the following matrix 2 by 2 matrix? So very simple. Calculate the eigenvalues for this. A minus lambda I, 2 minus lambda minus 1 minus 4, 5 minus lambda is equal to 0. 2 minus lambda, 5 minus lambda minus 4 is equal to 0. 10 minus 2 lambda minus 5 lambda plus lambda square minus 4 is equal to 0. So lambda square minus 7 lambda plus 6 is equal to 0. Right? So we will get here lambda square minus 7 lambda plus 6 is equal to 0. So lambda is equal to 1, 6. The eigenvalues are 1, 6. Right? Consider the system of equations a of n by n, x of n by 1 is equal to lambda of n by 1, where lambda is a scalar, and let lambda I and xi be an eigenpair of an eigenvalues of its corresponding eigenvector. For real matrix A, let 1 be an n by n matrix. Which of the following statement is not correct? Okay. Which of the following statement is not correct? For homogeneous n by n system of linear equations, a minus lambda 1 of x is equal to 0, having the non-trivial solutions, the rank of the a minus lambda I, actually here, a minus lambda I, right? A minus lambda I here is less than n. For matrix A raised to m, m being a positive integer and lambda I raised to m is equal to xi raised to m will be the eigenpair of all I. So if A raised to t, A transpose is equal to A inverse, then lambda I raised to m for all I. A transpose is equal to A inverse, then not correct. So the corresponding value, so B. B is the statement. For matrix A raised to m being a positive integer, then lambda I raised to m with an eigenpair for all I. Okay. Now, multiplication of the matrices E and Fis G. Matrices E and G are given. What is the matrix F? F is equal to E into G, right? F is equal to E into G. So, E and G are given. So, what is the matrix F? F is equal to E into G. F is the matrix E into G. So, calculate cos theta into 1 plus 0 plus 0. Cos theta 0 minus sin theta. So, identity matrix into this. So, you will get the option C. Just multiplication is there. You can calculate matrix multiplication. Now, match the least 1 with least 2. Right? So, which is the least 1 with least 2? A singular matrix. A singular matrix determinant is 0. Right? A is a singular matrix, determinant is 0. It means 3 options. B is non-square matrix. Non-square matrix, then determinant is not defined. B is 1. C is real matrix. So real symmetric matrix, eigenvalues are always real. And orthogonal matrix, determinant is always 1. So 2. 3142. 3142 option A. Okay. The rank of the matrix is, just calculate the rank, very simple. This is the question for the 1 mark. Rank of this matrix R2 minus R1, R3 minus R1, 1, 1, 1, R2 minus R1, 0, minus 1, minus 1, minus 2, 0, minus 1, minus 1. R3 minus R1, 1 minus 1, 0, 1, 1, 0, 1 minus 1, 0. Right? So rank of this matrix is 2. Here, rank of the matrix is 2. So P is given. P is equal to minus 10, minus 1, 3 transpose. Q is minus 2, minus 5, 9 transpose. And R is equal to 2, minus 7, 12 transpose. R, 3 vectors. An orthogonal set of the vectors having a span contain PQR is span of the matrix. So we can see the span of the matrix is contains P. We know that the see. Take any choice. Suppose we'll take the choice 6 minus 6 minus 3 minus 6 minus 3 6 4 minus 2 3. Then the span of the matrix will contain. So firstly this is orthogonal. This can be seen by the taking dot product. Minus 6 into 4 minus 24 minus 6 plus 18 plus 18 minus 6. So 24 plus 24 minus 24 0. So this is dot product is 0, right? The span were two vectors k1 into this and k2 into this, k1 into this, k2 into this. So span of this matrix is PQR is, so the correct option is A. So it spans your PQR. The following vector is linearly dependent upon the solution to the previous problem. Okay, linearly dependent upon the solution to the previous problem. So this solution is linearly dependent. We'll take the matrix 6 PQR minus 6 4 minus 2 minus 3 minus 2 minus 17 6 3 30, right? So span of this matrix is, you will get minus 6 determinant of this minus 60 plus 51 plus 3 into 120 plus 6, right? Plus 6 into minus 68 minus 4. If you see, the addition is 0, hence the linearly dependent. So which one is 6, 3, 40 minus 2? So option B. Minus 2 minus 17, 40. Now next. Solution for the system defined by the set of equations 4y plus 3z is equal to 8, 2x minus z is equal to 2, and 3x plus 2y is equal to 5 is, so x is equal to 0, y is equal to 1, z is equal to 4 by 3. So the augmented matrix for this system is given by 0, 4, 3, 8, 2, 0, minus 1, 2, 3, 2, 0, 5. Right? Now interchanging the row. Change the row. So you will get 2, 0, minus 1. R1 interchange with R2. 2, 0, minus 1. 2, 0, 4, 3, 8, 3, 2, 0, 5. Right? Now R3 minus 3 by 2 R1. So you will get 2, 0, 1, minus 1, 2, 0, 4, 3, 8, right? Now R3 minus 2 by 4 R2. For the last row, we see that 0 is equal to minus 2. So which is inconsistent. So rank of A is equal to 2 and rank of AB is equal to 3. So system is inconsistent. Non-existence. Solution is non-existent. For the matrix 4, 2, 2, 4, the eigenvalues corresponding to the eigenvector 101 and 101 is. So we will see here eigenvector corresponding to this is equal to 0. So 4 minus lambda into 4 minus lambda 4 minus lambda into 101 plus 2 into 101 is equal to 0, which implies lambda is equal to 6. Right? The value for this lambda is equal to 6. Now see, for a given matrix A, 2 minus 2 3, minus 2 minus 1 6, 1 2 0, one of the eigenvalue is 3, the other two eigenvalues are. One eigenvalue is given and the other eigenvalues. We know that one of the eigenvalues trace off. So lambda 1 plus lambda 2 plus lambda 3 is equal to a11 plus a22 plus a33. Right? Here a11 is 2 minus 1 plus 0. So sum is here lambda 1 plus lambda 2. One of the eigenvalue is 3. So lambda 1 plus lambda 2 plus 3. So lambda 1 plus lambda 2 is equal to 2 minus 1 is 1 and 3 is equal to minus 2. Right? So check which is having minus 2 sum. 2 minus 5 having the sum minus 3. Minus 2. Right? 2 minus 5. No. 2 minus 5 minus 3. 3 minus 5. Eigenvalues of the matrix S is equal to 3, 2, 2, 3 are 5 and 1. What are the eigenvalues for the matrix S square? We know that the eigenvalues is lambda square into lambda 1 raised to m, lambda 2 raised to m. So 1 square and 5 square. 1 square is 1 and 5 square is 25. So A is the correct option. The eigenvalues and the corresponding eigenvectors of 2 by 2 matrix are given by eigenvalue and eigenvector. Lambda 1 is equal to 8. Lambda 2 is equal to 8. So V1 is equal to 1, 1. V2 is equal to 1 minus 1. So we will get the matrix is, so here trace of A. Lambda 1 and lambda 2, 8. Lambda 2 is here 4. Lambda 1 and lambda 2 is equal to lambda 1 plus lambda 2 is 4. A11 plus A22. So 12 is equal to, which is having 12 A. 6 plus 6, 12. Right. A is the correct option. Now, a square matrix which is neither symmetric nor skew symmetric and A transpose is a transpose. The sum and difference of these matrices are defined as S is equal to A plus A transpose and D is equal to A minus A transpose respectively. Which one of the following matrices statement is true? Okay, for the skew symmetric matrix, we know that skew symmetric matrix is S transpose is equal to S, matrix is symmetric. S transpose is equal to minus of S, then it is skew symmetric, right? So S is given A plus A transpose. Now S transpose is equal to A plus A transpose transpose. So S transpose is equal to A transpose transpose is A transpose is equal to S transpose is equal to A, which is equal to A transpose, which is equal to S, right? So S is symmetric, right? So skew symmetric, D transpose. A minus A transpose. So minus D. So skew sir. So D is skew symmetric, S is symmetric. So D is the correct option. Okay. Are you getting it? D is the correct option. Now the inverse of the 2 by 2 matrix 1, 2, 5, 7 is. We have to calculate the inverse. To calculate the inverse of ABCD is 1 upon AD minus BC into D minus B minus C minus A. Inverse is equal to 1 upon AD minus BC into D minus B minus CA. AD 7 minus 10. Minus and multiply. 1 by 3 into minus 7 plus 2. 5 minus 1. Option A is the correct option. x is equal to x1, x2 up to xn transpose is a n-tuple non-zero vector, then n by n matrix V is equal to x into x transpose has rank 1. Has rank 1. Simple question. It is given that x1, x2 up to xm are m non-zero orthogonal vectors. The dimension of the vector spanned by the two m vectors. This is the 2 marks question. Will also span the, since x1, x2 up to xn are orthogonal, they span the vector space of dimension m. Since minus x1 minus x2 up to minus xm are linearly dependent on x1, x2 up to xm, right? So this set will also span the vector space of dimension m only. So option C. Consider the set of column. Consider the set of column vectors defined by x is equal to x belongs to R3 such that x1 plus x2 plus x3 is equal to 0, where xt is equal to x1, x2, x3 transpose. Which of the following is true? It must be spanned to the basis for the subspace of S. The two conditions are there. The vectors have to be linearly independent and they must span X. So which will span the vectors. So 1 minus 1 0 transpose and 1 0 minus transpose is the basis for the subspace X. Now it is linearly independent, right? First these vectors are linearly independent. Now once these vectors are linearly independent, obviously this will span. So 1 minus 1 0 and 1 0 minus 1. So the rank of this matrix is 2. Okay, so this is linearly independent and rank of this matrix is 2. So definitely this will spans the vector space. A is the correct option. For what values of alpha and beta, the following simultaneous equation have an infinite number of solutions. So for that we have to calculate the augmented matrix. 1 1 1 5, 1 3 3 9, 1 2 alpha beta. So R2 minus R1 so beta minus 5. So we'll get R1, R3 minus 1 by 2 R2, 1 1 1, 0 2 2, 0 0 alpha minus 2, 5 4 beta minus 7. So now the infinite solution for the last two row must be completely 0. For infinitely solution, last row must be completely. When beta minus 7 is equal to 0, which implies alpha is equal to 2, beta is equal to 7. A is the correct option. Alpha 2, beta 7. Okay. Now next. The number of linearly independent eigenvectors of A minus lambda I is equal to 0. So 2 minus lambda, 2 minus lambda 1, 0, 2 minus lambda. So lambda is equal to 2. Right? Now consider the eigenvalues here. So A minus lambda I is equal to 0. 2 minus lambda 1, 0, 2 minus lambda. Now put lambda is equal to 2. So you get x2 is equal to 0 and x. So the solution x1 x2 which is equal to k0 which is equal to k into bracket 1 0. So eigenvector for this is 1 0. Only one eigenvector, that is B. Yeah, only one eigenvector it will give. Now, the linear operation L of x is defined by the cross product L of x is equal to B cross x, where B is equal to 0 1 0 transpose, x is equal to x1 x2 x3 transpose are three-dimensional vectors. The 3 by 3 matrix M of this operation satisfies L of x is equal to M of x1 x2 up to x3. Then the eigenvalues of M are, okay, we will calculate the eigenvalues for this. Cross product for this B cross x, 0 1 0 x1 x2 x3, x3I plus 0j minus x1k. Okay, x3 0 minus x1. Now L of x is equal to B cross x M into x1 x2 x3. M is 3 by 3 matrix, right? M is 3 by 3 matrix. So M you can treat anything here. Suppose C1, C2, C3, C4, C5, C6, C7, C8, C9. So now for M of x1, x2, x3 is equal to B cross x. So let's consider C1, C2, C3, C4, C5, C6, C7, C8, C9 into x1, x2, x3 is equal to x3 0 minus x1. So by matching LHS and RHS we get here 0 0 0 1 0 0 0 minus 1 0 0 of x1 x2 x3 is equal to x3 0 minus x1. So what will be the value of M? M is equal to 0 0 1 0 0 0 minus 1 0 0. Right? Now we have to find the values of M. So M minus lambda I is equal to 0. Question of this, M minus lambda I is equal to 0. Now I am rubbing out this. So we will do okay. Determinant of M minus lambda I is equal to 0. Right? Lambda is equal to 0, lambda is equal to plus or minus 1. Plus or minus I complex term. Plus I minus I am 0. Right? These are the eigenvalues. Now, the minimum and maximum eigenvalues of the matrix are minus 2 and 6 respectively. What are the other eigenvalues? Okay, minimum and maximum. We know that summation of eigenvalues are here lambda 1 plus lambda 2 plus lambda 3 is equal to a11 plus a22 plus a33. Right? So here 2 lambda 1 minus 2 plus 6, 1 plus 5 plus 1. So plus 4, 7. So lambda is equal to lambda 1 is equal to 3. The correct option is B. Okay. The correct option is B. Now let's further. If a square matrix is real and symmetric, then the eigenvalues are always real and positive. Simple question. Sorry, always real, not always positive. Okay. So A satisfies the relation A plus 3i plus 2a inverse is equal to 0. Then A satisfies the relation. So A is given. Actually for this matrix A is given minus 3 2 minus 1 0. Now A satisfies the relation. So using Cayley-Hamilton theorem, every square matrix satisfies its characteristic polynomial. So A is given, find out determinant of A minus lambda I. Minus lambda is equal to 0. Minus 3 minus lambda into minus lambda, minus of minus plus 2 is equal to 0. Plus 3 lambda plus lambda square plus 2 is equal to 0. So every square matrix satisfies its own characteristic polynomial. So a square plus 3i plus 2a. So what we will do, we will multiplying by a inverse. So here 3a plus 3a square plus 2i. Multiplying by a into a inverse 3i plus a plus 2a inverse. So option A. Right? Now a raised to 9 equals to. So here we can find out a raised to 9 equals to every square matrix satisfies for the same matrix. Okay. So after doing a raised to 4, you can calculate a raised to 4 is minus 15a minus 49. A raised to 8 is equal to a raised to 4 into a raised to 4. Right? So after calculating, after doing all this calculation, you will get option A. Okay. I hope you are getting it clearly. I tried to cover up many questions from the GATE exam. Okay. So there are many questions are remaining here, 2, 4, 2, 5, 7. So you can go through it and see. The next question we will solve in the next lecture. I hope you are getting it clearly. Okay. If you are liking my videos, please do like, share and subscribe. Thank you so much. And don't forget to press the bell icon. Okay. Thank you so much.